Okay, so, like I said, we're kind of working backwards a little bit today because you've already done the absolute value inequalities. Now we're going back to the linear ones. So this should make life a little bit easier. The one thing I do want you to kind of pay close attention to here, that's going to be, again, if you either multiply or divide by a negative number to solve, make sure you reverse the inequality. In other words, you flip the arrow around. Kind of careful with that. Always a good idea. And also that we're going to be writing our solutions in interval notation. Now I made a note over here about which of your inequality arrows are going to go with what symbols. The one thing I forgot to mention on here, we talked a little bit about it before, but I want to make sure we get this down, is that when you're looking at a graph, because a lot of times we look at a graph to figure out the interval notation, it just makes it easier. If you have a graph that's heading off to the left, and I'll just put a symbol on it just to be able to do that. Remember, that graph is starting, we go left to right with interval notation. So left would be negative infinity to, well, whatever value this happens to be. Because we don't know what value that happens to be in this case. And oppositely, if it starts with a symbol and goes forever to the right, that'll be whatever this initial value is, and heading off to positive infinity. The symbols matter. The negative or positive matters. They're not interchangeable. I never want to have positive infinity on this side. I never want to have negative infinity back on this side because we want to make sure we're showing that left to right relationship. So when we start actually getting into some of these down below, solve them just like you would a regular equation. You're like, okay, if I'm solving for 5y, I'm going to add the 8 over, and then I'll just divide by 5. So when I get done, one thing I think I mentioned yesterday, I hope I did. If I didn't, I'll mention it again now. Whenever you're doing these lines, you at least have to have 3 values. I don't want to just see 4 in the middle and here we go, because I want to make sure our number sense is going okay. So typically, I'll just use 1 value on each side. But you have to be consistent. Like I can't use 4, 0, 25 here. You need to have equal values between your lines, whether that's 1, 5, 10, whatever. So here I go, okay, y is less than, arrow's pointing at the y. So we know we're going to be heading left. And less than is just going to be a parenthesis because it's not or equal to. Get my graph. But we're also going to be doing interval notation with all of these. So like we just mentioned up above, since I'm going left to right, I'm starting at negative infinity because this arrow goes infinitely to the left, and infinity is always a parenthesis. And I come up to my stopping point at 4 and just use the same symbol that I already got. Nothing too bad. And on any of these, that's basically going to be all that we're doing. It's kind of an Algebra 1 review with a couple of graphs thrown in. Here I'm going to minus my 5 over. And then divide by negative 2, but remember what we mentioned up above. If I multiply or divide both sides by a negative, which I'm doing here, I have to reverse or flip the inequality arrow. If I forget, I'll get exactly the wrong answer. I'll get the wrong half. So once I get that, and again, this is why I do this for number sense. You'd be surprised at the number of people that put negative 10, negative 11, negative 12. And I'm like, no. Because remember, your lesser values are always to the left. And with negatives, it takes on just the opposite of what you would think. I'd rather owe somebody $10 than $11. I'd rather owe somebody $11 than $12. I like to think about it with money if I get confused sometimes. I always want the best situation for me on the right. All right, so we're less than again, but it's or equal to. Less than still heading left. And so my interval notation is going to look very similar. Again, infinities always get parentheses. And then when I hit that stopping point, always make sure that you use the same symbol. Because again, symbols matter. This means I include negative 11 in my answer. This means I come right up to 4, like 3.9999999, but I don't take 4 in as a solution. And that's what I'm trying to deal with. Okay, 3, I'm always curious on what people think they should do first. What should I do first on number 3? Okay, good. A lot of times I'll have people say, oh, I'm going to multiply by 2. And they'll multiply this by 2 and this, and they forget about the 7, and then it's wrong, it's bad. Very good idea to get the 7 out of there first, because now when I go through and multiply, and again, I just do it by the reciprocal. You can do it in 2 steps by multiply 2 and divide by 3 if you want to. But I just find it easier to do it that way. And then 9 times 2 is 18, divided by 3 is 6. Get my values in on the other sides. We finally have a greater than. And again, don't get sucked into thinking the arrow will always just tell me what direction it's going. That's true if x is on the left side. But if for some reason sometime your variable ends up over here, you've got to watch for that. Because if you just follow the arrow, that's going to get you sometime. So this time we're heading to the right with greater than. I actually start at my point this time. I don't start at infinity, but I go. What I do? Don't. International teacher goofiness. Yeah, I hadn't mentioned before. Sometimes I'll go into little side things because it's fun when people are watching these online. It gets them back in instead of wanting to turn me off. As we start working on number 4, I can tell you a quick story here on what occurred last year with my channel. My YouTube channel, I'd always said I was going to have like a party when I made it to 10,000 views. And so I'm like, that's going to take a while because people use it on and off, stuff like that. Well, over a 2-month period, I went from like 3,000 views to like 20,000. And I'm like, okay, what's going on here? I found out that somehow there was a very small school in Africa, and if you guys are still watching, hey, he actually wrote to me and said he was using my stuff to actually teach their algebra class over there. So that's why I ended up having higher viewing portions in 3 foreign countries and 4 states than I did in Illinois. So people everywhere else like my videos. My own students just don't like them. So yeah, occasionally I'll say something just in case somebody somewhere else is watching. I need to learn how to speak in a different language too, so they can, but not really. I do this for my own students, not for other people. No offense, other people. Okay, back off my little tangent here. This is the situation I was just talking about. If I just follow the arrow, which is not a good idea, I'd have my arrow going to the left here, and I'd be taking the wrong half of my graph. X is still greater than. Whenever the arrow is eating X, even if it's over here, greater than, get my symbol right this time, is going to be heading to the right. And so my interval notation follows that along, which is why I like to visually see what's going on. So we're going to be seeing lots of infinity in this section with our linear inequalities because, well, we're not going to be seeing as much go in both directions. I'm just going to do one more here. I'm going to go to 5, then I'm going to jump ahead a little bit here. So we'll get our distributing in here first. I'm always a big fan of keeping the x's positive at any cost. So I'm going to add the 5x over. And we'll subtract the 12 back. And again, be cautious. My x is not in its normal comfortable spot on the left-hand side, at least the way I did it. Some of you will want to keep putting your variable on the left side at no cost, and that's fine too. So x is less than or equal to -7. This time I get to use my bracket. And again, since we always work left to right, left starts off at negative infinity with my arrow and comes until I get stopped at negative 7. So basically, if we're strong with our Algebra 1 skills, this stuff is not too bad. Compounds, shoot, you already got an intro to that yesterday now. Okay. We get into talking about the and or type stuff that we were talking about at the beginning today. And problems are restrictive. They have smaller solution sets. They come together. The or problems are non-restrictive. They go out and go forever and ever. So they have huge, huge solution sets. So when we see the word and, we get things that look like this with our compound inequalities. So then we can go, okay, so if x is greater than or equal to negative 2, that's worthy of a bracket. But x is less than 1, worthy of a parenthesis. We can mix and match with those. They can be the same, they can be different. And then my interval notation, if I was asked for that, would go from left to right. Notice, same symbols I see on the graph are the same symbols that I'm going to use on the sheet. Similarly, just flip to the back here. When we get or working in the middle, I don't have to rewrite anything, but as I graph them, x is less than negative 1. X is greater than or equal to 2. Again, ors go out. They both start with O. It's an easy way to remember what your graph should look like. And if I do interval notation on something like this, again, I start at the left, which is off at negative infinity, until I hit that first stopping point at negative 1. But I'm not done. So I use the U, the union symbol, to say, okay, there's two parts to this. I want you to make sure you see both. And then I go until I start up again at 2, and it goes off forever to positive infinity. So you'll start to notice, okay, these are a lot like what we were doing with that stuff yesterday. So I'll just do one of each of these, make sure we're clean, then I'll give you some time here, and I'll show you how we're going to trim some of the assignment down here somewhat. So here, treat it like you would any equation, except now you have 3 sides instead of 2. Add your 8 to all 3. And since the work is trying to get t alone in the middle, we'll just divide all 3 parts by 3. So let's see here. And again, you could count by 2's here, whatever it is you want to, as long as you're getting equal values for each line. So we know this is like an and statement. We know how the ands work. They get all together in the middle. And I can do it that way. If you want to do it separately and say, hey, t is greater than 2, okay, that's going to the right. T is less than 6, that's going to the left. Oops, they whack in the middle, I'm good. That's fine. So you can kind of see how that works. And then with our ors, I'm going to jump into the middle to number 12, and then we'll see if we want to do any other ones that look interesting or if we're good. Ors, we just got 2 separate inequalities, so I'm going to solve each separately. And again, be cautious. Sometimes we can get a little flip happy. Like you look at number 12 and you're like, ooh, I see a negative and I divide it. I have to flip it. Only if you're dividing both sides by a negative. Since I'm just dividing by positive 6, no flipping needed here. Add my 8 over. Okay, so I've got my values. Now I notice I don't think I have enough lines for all of these. So this time maybe I'll count by 2's. So maybe I start with negative 1 and I just decide I'm going to go every other value. Perfectly fine. Like I said, as long as it's an equal value between, I keep going up by 2s, that's fine, or whatever value I happen to use. So here, they're ORs, so I know they're going to go out more than likely. Less than -1. Greater than 7. Well, greater than or equal to 7. That was bad. I didn't do my interval notation on 8. Got to go back and do that here. Again, interval notation on ands are going to be really small. It's almost going to look like a coordinate point, but it's not, because that's telling me all the values that are in between those. But the ORs, those are the biggies. They're going to be there. I'm going to be like, all right, starting at -infinity. Pit stopping at -1. And then I'm starting up again at 7. Going off forever to the right. And I'm good to go. And that's basically all we're doing in this section. We're kind of doing a rewind of what we were doing before. So let me explain what you've got on your plate, and then if there's some other ones on this sheet you want to take a peek at, we can. So this is the actual assignment. Just some practice with basic graphing on some of them, kind of working through some different types of problems, seeing how it works. But then let me make note on the back so you don't overdo yourself. When you get to the back, here's all this book. Okay, here's the only thing I want. $45. That's the only book problem I need, because it's got something different than all the rest of these do. Everything else in that book assignment is just a repeat of the 20 problems you have here. We don't need overkill. Overkill is bad. So if you can knock out this worksheet, maybe just stick number 45 from page 39 on the bottom here, perfect. We can have that set and get you ready and raring to go as far as that goes then.